Hello guys, welcome to today's class. So for this particular lecture, we'll be looking at application of electromagnetic fields. We have already discussed electromagnetic field and the force on a current carrying conductor in a magnetic field. We've discussed Fleming's left-hand rule, and we did some calculations. Alright, so today we are looking at application of electromagnetic field. So we're going to see different areas where electromagnetic field is applied in our everyday life. Okay, so this is Normal Science Tutors Online. If you are just coming or you are just visiting this channel for the first time, you are welcome. Here we are discussing physics right from the beginning to the end, so please endeavor to subscribe so that you will have access to all our videos. And not only that, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Right, you can reach us through the WhatsApp link that is showing right down your screen. Give us a positive comment, give us a like, invite your friends too. That's okay. Invite your friends, and so that they can come and enjoy what you are enjoying here. All right. So as I said, um, I'm Otobo Michael, and I'm your online physics instructor. Okay. So today we are looking at application of electromagnetic field. So we'll be looking at the electric motor. We'll also look at the galvanometer, because these are areas where electromagnetism is applied. So we'll look at the galvanometer and the electric motor. All right. So if you are ready, please let's go for the class for today. All right. So as I said, we are looking at application of electromagnetic field, and the first application that we have here is the electric motor. Okay. So this is just a typical sketch of the electric motor. The electric motor, what it does is that it converts electrical energy to mechanical energy. Right, that is what it does. It converts electrical energy to mechanical energy. We know electric motor, those are what we use, like our pumping machine. Yeah, the pumping machine in your house is an electric motor. Yes, it converts electrical energy that you pass into it to mechanical energy, and that mechanical energy is what drives the impeller that pumps your water. So that is a typical example of an electric motor that you have on everyday use. Then you also have electric motor in some of your devices. Okay, you have electric motor in some of your devices. If you are used to different electronic devices, you have small motors in them, that helps to drive some beds, drive some components of the machine, like your printer. Your printer has electric motors in them and all that. So those are areas where you can actually see electric motors. Now, what is the component of an electric motor? The components are that one, it has a rectangular coil. Not all electric motor has a rectangular coil. Some could be circular coil, as the case may be. But for this particular discussion, an electric motor has a rectangular coil. The coil is called an armature. So this is the coil. Okay, so this is the coil here. Okay, you can see it here. This is the coil, and this is the coil. All right, it has a powerful magnetic field, in which the armature turns. So these two magnets that are placed out, they are very powerful magnet that produces a very powerful magnetic field in which the coil can turn. Okay, then there's a commutator split ring or copper. This is the commutator split ring. Okay, look at it here. This round one is a commutator split ring. What it does is help to reverse currents. Then you have the carbon brushes. There are two carbon brushes. So these are the carbon brushes that allows current to come in or go out. Okay, so if you open a typical electric motor, you will see the carbon brushes, right? You see the carbon brushes on the electric motor. So these are the components of the electric motor. All right. So what is the working principle of this electric motor? How does it work for you to give you the mechanical energy that you want from it? How does it work? The working principle of the electric motor. So this is an electric motor, right? And these are the components and everything. So when this coil is in the horizontal position, it is assumed that current flows through the coil from the battery in a clockwise direction. Okay, so this is your battery source, and so it is assumed that current flows through it in a clockwise. That is, it goes like this and comes, and then it goes like this and comes, just like that, right? So at this point, an upward force acts on the arm AB of the coil, and a downward force acts on the side CD of this particular coil. So there's a rotation in this direction. Now, the two equal and oppositely directed forces constitute a couple whose torque causes the coil to rotate in a clockwise direction. So as far as this force is coming this way, right, there are equal and oppositely directed forces, so they constitute a couple. And you know that the effect of a couple is what? It is rotation. All right, so it causes the coil to rotate. The split rings, these are the split rings to which the ends of the coil are attached, rotate along with the coil, and the momentum of the moving coil carries it through the vertical position. Beyond the vertical position, the two halves of the split rings commutator automatically changes contact from one carbon brush to another carbon brush. So that is to tell you that these carbon brushes, they are not fixed to the split rings. It is only the split ring that is connected to the coil. The carbon brushes just make contact with the split ring, so the split ring is free to rotate along the carbon brushes. It is the carbon brush that allow current to touch the split ring. Okay, so the split ring, because it's rotating with the coil, they will change position. Okay, so like this right one will be to the left, and this left one will be to the right. And we change contact, automatically change contact from one brush to another. This reverses the direction of the current flow in the coil, and hence the direction of force on the coil. Side AB will now experience a downward force, while side CD will experience an upward force. Okay, so the coil rotates through half a turn more, where the current again reverses by means of the sliding brushes and the split rings commutator. A repetition of this process at each half turn gives rise to a continuous rotation of the coil as long as the current flows through it. So this process of the split ring changing carbon brushes continues. All right, so it continues, and then the rotation of this coil also continues too. So that is the working principle, and as it is carrying, as that rotation is taking place, mechanical energy is being produced. Okay, so that mechanical energy can be used to turn any piece of equipment. Yes, because in the industry, electric motors are used to drive fan belts. Okay, and then the fan belt might be connected to another equipment, maybe to a a conveyor or whatever. All right, so electric motors, they are very key in industries. They use them in for industrial purposes. All right, so this is the working principle of the electric motor. All right, so the efficiency of this motor can be increased. One, if the armature has more loose of wire on a laminated soft iron drum. So if the armature is made with a soft iron is normal iron. So when you say iron is soft, it doesn't mean that you can press the iron, then the iron will depress. No, we've discussed this before. Steel is hard iron, normal iron is soft. So that is just, it's not like the iron is soft like a plastic. No, so if you use a soft iron, a very good soft iron as the core, then you have more wires or more windings or more wire loops around it, it can increase the efficiency of the DC motor, right? Then if you use strong magnet that can produce strong magnetic field, that one is another factor that can increase the efficiency. Then the current flowing, if you increase the current that is flowing into the system to, maybe you connect a rheostat, right? You have a rheostat and a galvanometer connected to it, you can adjust the current that is coming into the system. All right, so if you have a galvanometer and a rheostat, you can adjust the current, and then you will have more, you have the efficiency of the machine will increase more. Okay, now while the machine is working, there is also energy losses, and that is why one one area where the machine loses energy is one, work done against friction in the bearings and commutators. Yes, as the machine is rotating, with time, those area of the bearing will start to get hot. So the work done against friction can make it to lose energy. Eddy current, they are current that opposes motion. Okay, current that opposes motion in a magnetic field. Eddy current, they are induced current that opposes motion in a magnetic field. So the eddy current form in the soft iron cylinder can actually make the electric motor to lose energy, and this is reduced by laminating the cylinder. Okay, then heat losses in the windings. Okay, so there could also be heat losses in the windings. So these are areas where the equipment can lose energy. So you need to take note of this. These questions, you can have them in your theory part of your physics. Okay. Another application of the electromagnetic field is in a moving coil galvanometer. Alright, so we've discussed galvanometers in some of our other lectures. So we want to see the working principle of the galvanometer and how it relates to electromagnetic field. Okay, so the galvanometer, this is a picture of a typical galvanometer, right? So your galvanometer has a scale, and the galvanometer is actually used to measure accurately very small currents. Okay, it's used to measure very small currents. Okay, so this is what is inside a galvanometer. Okay, so a galvanometer is one of the most sensitive and accurate device for detecting and measuring extremely small current or potential differences. It is calibrated in millimeters. So this scale that is here is in millimeter. The galvanometer, what does it consist? It consists of a rectangular core, just like the electric motor. So if you look at the picture of this galvanometer, it is exactly like the electric motor. Okay, so it consists of a rectangular core of one rounded soft iron core called the armature, placed between the pull end of a magnet, and that is the picture I are seeing here. The coil is placed so that it can rotate in the magnetic field when an electric current is passed through it. That is exactly what we discussed in the electric motor. Now, the extent of rotation is indicated by a pointer attached. This pointer attached to the coil spring. Look at the spring, which in turn enables the strength of the current to be measured. So what is the working principle of the galvanometer? As we discussed for the electric motor, their working principle, they are almost the same thing. Okay, so the current to be measured is passed through the galvanometer from a terminal through one of the spring and leaves through the other spring. So the current comes in and goes out like that, right? So when current flows in the coil, forces out on the arms A, B, and B and C, D, exactly as we discussed in the case of the electric motor. Here too, there is still a couple is formed because there are two opposite forces. So two opposite forces constitute a couple whose torque tends to rotate the coil in a clockwise direction across the radial magnetic field provided by the magnet and the soft iron core. Exactly what we mentioned in the case of electric motor. Now, something happens here. The movement of the coil is opposed by the spiral springs, and the coil will come to rest in a position where the couple, due to its current, is exactly balanced by the control couple produced by the spring. The angle of rotation is thus controlled by the spring. So the angle through which the coil rotates is recorded by the pointer attached to the coil. This angle is proportional to the size of the force, which in turn is proportional to the current. The scale reading of the pointer will therefore give a measure of the current. What all this is telling you is that when the current comes into the coil, there's a couple. That couple will cause this coil to rotate because the torque of a couple is rotation. Alright? The torque of a couple is rotation. So this coil will rotate in the magnetic field of these two magnets that is here. Now, as the coil is rotating, the spiral spring will oppose that rotation. So that will make this pointer to come to rest where the couple, due to the current, is exactly equal to the couple due to the spring. So just where the force of the current is equal to is exactly equal to the force of the spring will come to rest. Now, the angle through which the coil rotates is recorded by the pointer attached to the coil. This angle that is recorded is proportional to the size of the force, which in turn is proportional to the current. So all this information will be recorded on this scale. The scale reading of the pointer will therefore give a measure of the current. So the measure of the current is equal to the force that is produced. Is that okay? It's equal to the force that is produced because the force is proportional to the current. So it is this pointer that will help you to detect the current that is produced. Alright, so how can you increase the efficiency of this particular instrument? That is the next thing that I want to discuss. How can we increase the efficiency or the sensitivity of the galvanometer? The sensitivity of the galvanometer is the ability of the galvanometer to detect very small currents, while the accuracy of the galvanometer is its ability to indicate current values very close to the true values. This sensitivity of the galvanometer can be increased, one, by increasing the magnetic field if the magnetic field is made to be very strong, and this you can do by using very powerful magnets. If you increase the number of turns on the rectangular coil, it will help you to be very sensitive. The spring that is used should be very tiny so that it can easily swing or twist. Then the area of the coil should be increased. All this one will increase the sensitivity of the galvanometer. Don't forget that this same factor these are the factors we also listed for the electric motor. If you want to increase the efficiency of the electric motor, it is the same thing that I had to. So don't forget. Advantages of the galvanometer: one, it has a uniform scale. The scale is graduated in millimeters, right? No extra measure needs to be taken to shield the instrument from stray magnetic field due to its strong magnetic field. By fitting a suitable resistance, the instrument can be made to read different ranges of potential difference or current. Don't forget that we have treated conversion of a galvanometer to an ammeter and to a voltmeter. You want to convert a galvanometer to an ammeter, you put what? A shunt, a low resistance shunt. Then if you want to convert it to a voltmeter, you put what? A high resistance multiplier. So the galvanometer can actually be converted to read either potential difference or current, as the case may be. The high sensitivity enables very small current to be detected. The only disadvantage of the galvanometer is that it cannot be used to measure alternating current, right? Because alternating current rapidly changes direction, and the galvanometer does not work in that way. Alright, so these are basically the information. These informations, they are very key and you need to take note of them as you are preparing for examinations. Alright guys, so this is where we're ending this class. Thank you so much for your time. You are welcome to Nobleman Science Tutorials Online. If you are just coming, I hope you have enjoyed our class, and we beg you that subscribe to our channel, give us a thumbs up, give us a like, give us positive comments, click on the notification bell so that when we upload a new video, YouTube will notify you. Thank you so much. We appreciate you for coming. Please continue to read your textbooks, review past questions. In a short while, we are going to treat some past questions, that we're also going to treat examiners' comments on some questions, right? So that you know how to go about. So that video will just be on secret to your passing your examination with ease. So we'll come to that in a very short while. All right, so thanks and have a nice day.